Store documents and collections, conjure them with projections, update, remove, insert, and find its schema list. Keep this in mind, NoSQL looks like wizardry in the magical marvels of MongoDB.
You're watching the magical marvels of MongoDB. I'm Joel Taylor, and throughout this course, we'll be interacting with the Potion Review application. We'll be using MongoDB as a backend database to store and retrieve our potions. These reviews will consist of the strength, the flavor, and the grade. This course consists of 5 levels. First, in Conjuring MongoDB, we'll look at the basics of Mongo and learn how to insert and find our documents. Next, we'll look at how to update and remove them, perform advanced queries, learn some best practices for storing our data, and lastly, we'll see how we can combine data for interesting reports. So get ready, sit back, relax, and enjoy the course. To start off, let's first answer the question of what is MongoDB? Well, Mongo is an open source NoSQL database. Now the term NoSQL can be a little difficult to define, but for this course, we'll refer to it as databases that generally aren't relational and don't have a query language like SQL. Mongo is document-oriented and it's great for unstructured data, especially when we have lots of it. MongoDB first came into being back in 2007 when it was developed by a company called Tengen as a part of their product. Unfortunately, they didn't generate as much interest as they wanted to, but instead of scrapping everything, they thought their database was really great, so in 2009 they open sourced it. And since then, it's gotten so popular that in 2013, Tengen renamed themselves to MongoDB. They might be wondering, where does the name Mongo come from? It actually stems from the word humongous. MongoDB shares a lot of similarities with a SQL database. At the lowest level, they both store their data in a database. In SQL, the database is made up of tables, whereas MongoDB is made up of collections. Tables are made up of rows, but in MongoDB, collections are made up of documents. So for SQL, data is stored in a row that gets placed in a table, which is saved in the database. For MongoDB, documents get grouped in collections, and collections are stored in the database. So what's the big difference? Well, SQL is relational, while MongoDB is document-oriented. Let's take a closer look at what it means to be relational. Let's imagine we have a love potion that costs $3.99 and is made by a company called Brewers. To store this in SQL, we'd have a potions table with the potion ID, name, price, and a vendor ID column. Then we'd have a vendor's table with the vendor ID and name column. You'll notice that the love potion has a vendor ID of 2, which creates a relationship with the vendor in the vendors table that also has an ID of 2. On the other hand, document-oriented databases would take the information about the potion and group it all together in a single document. All those documents then get grouped together in a potions collection. You can think about this like you're filling out a form that contains everything you need to know about the potion. So we've learned that collections are just groups of documents, and documents exist entirely on their own. This means we can store completely different documents in the same collection. For instance, here's our potions collection with 3 potion documents. We might have one that has the name, price, and vendor information, another with only name and price, and then one with name, price, and even danger information. This is referred to as a dynamic schema, which means potions can have different data. This is why MongoDB is great for unstructured data that's still related. Now we've covered the fundamentals, let's break into some code. One place to write Mongo is in the shell. To do this, in the command line we type Mongo, which then puts us in the shell. We can write our commands after the greater than sign to interact with our database. We'll be providing the shell in the browser during challenges, but if you want to set up Mongo on your local computer, you can head over to their installation instructions online. As we just saw, all instances of Mongo come with a command line app called the shell, which is just a JavaScript interpreter that lets us write JavaScript code. As you can see here, we can perform basic variable assignment, access the variable to see the contents, and get a response back. This is all just normal JavaScript. Documents, which is where we store data in Mongo, are just JSON-like objects. These objects are surrounded by curly braces, consist of field value pairs. In this example, we have a field with a string name and a value with a string invisibility. Then we have a field with the string vendor and the value with the string kettlecooked. We can have as many field value pairs as we like. All we have to do is separate them with a comma. Let's look at a few basic shell commands. MongoDB comes with a number of helper methods to make it easy to work with our database. We'll be using a database called reviews. To get started, we can select which database we want by typing use reviews. We'll get a response back saying that we switched to the database reviews. If that database doesn't exist yet, it will get automatically created for us when we write to it. To check which database we're currently using, we can simply type db and we'll get a response back saying reviews. If you ever forget a command, you can always type help, which will give you a list of helpful commands. For instance, show DBs will give us a list of all the databases and their names and sizes. Here's our Potion document. Now we can't just store this document in the database. If we did that, it'd be a complete mess. First, we have to store the document in a collection, and that collection gets filed in the database. So we're going to create a collection called Potions. We'll put that Potion document in the Potions collection, which then gets persisted in the database. We can use the insert method to save our Potion document in the Potions collection. First, we type db. Whenever we interact with the database, we always use db first, followed by the collection name. In this case, we'll put the collection Potions. What's cool here is although we haven't actually created this collection yet, it'll be created when we insert our document into it. So next, we add insert with parentheses. We'll then pass the parameter of our Potion object. When we run this code, we get back a response that has the words write result, but we didn't conjure this, did we? Well, it turns out that whenever we create, update, or remove a document, we always get a write result back to let us know if the operation was successful or not. In this case, we have n inserted, which stands for the number of documents inserted, and the value of 1. This lets us know that one document was successfully inserted into the Potions collection. In order to retrieve our document, we'll use the find method. Just like we did with inserting, we'll first type db followed by the collection Potions, and then the find method. Even if we don't pass any parameters to a method, we always end them with parentheses. Let's give this a try, and just as we expected, we successfully retrieved our Potion document. But wait a second, what's that _ID field with the weird object ID value? MongoDB requires that each document has a unique ID. Since we didn't specify one, it automatically created one for us. The find method will return all the documents in the collection. To see this, we'll add 2 more Potions. As you can see, we have 2 successful write results. Running find again will return all 3 documents. Now that you've learned the basics of MongoDB, go try creating and finding your own documents in the challenges.